Okay, so here are the first few log rules. The first one I call the log rule of multiplication, and that's because you can multiply these two and they split into the sum of the logs of m and n. The next one I call division, because you divide m by n and you can split them into logs m take away n. This is the power of 1, equivalent to the index law a to the power of 1 equals a. And the other one is the power of 0, and that's equivalent to the index law where a to the power of 0 is 1. Alright, now this next one is what I call the negative power one, and that's just changing the 1 on n into n to the power of negative 1, which then turns into negative 1 times log a of n, which we drop the 1. The next one hasn't really got a name for me. Basically, if you have that power up there, you can drop it down to the front. And obviously, if you have log a of a, then the n can drop down to the front, leaving behind the log a of a term. But hopefully you remember that that actually equals 1 anyway, so you don't actually write it in. And the last one is a base conversion one, and it's not always on the official list. But basically, if you have log to the base a of m, you can work it out using a different base, as long as you put the m in the numerator argument and the a in the denominator argument. Alright, so to convert from index form to logarithmic form, and vice versa, I see it as a bit of a football game. So if we start at this side, to convert it to log form, you move that a across as a base, which drops the n downwards, giving you log to the base a of y equals n. Now if you want to go backwards, you have to kick the a across over here, which means that n gets moved up as a power. So here's an example. Write the following equation, which is in index form, which is 10 squared equals 100, in logarithmic form. So what we do is we take the base 10 and bring it across here, which means that 2 will drop down, like so. So here's one example. You've got to simplify this log expression, and we can do it a couple of ways. So I'll do it two ways. The x method is to call that term as x and then rewrite it in index form. So that means we'd kick the 3 across here, which means you get 3 to the power of x equals 1, and then you'd have to write the 1 as 3 to the power of 0. Then, because you have the same base, you can equate the indices, so you get x equals 0. So therefore the final answer is log to the base 3 of 1 equals 0. The other method is rather more straightforward. It relies on your noticing that this is a 1 here, and you can use the power of 0 log rule, which means that that is just equal to 0. And how you'd remember it is, anytime you see a 1 in the argument, you can work out that the answer is going to be 0. Here's another one. Again, we'll have two methods. If we do x equals log to the base 2 of 2, then you can kick this 2 across here as a base, which means that x goes upwards. So you get 2 to the power of x equals 2, and you should be able to recognize that 2 can be written as 2 to the power of 1. And then because the bases are the same, you can equate the indices, so you get x equals 1. So the log to the base 2 of 2 equals 1. Now the short way of doing it is to notice that you have log of 2 to the base 2, and that's the same base. So anytime you see them together, you can pretty much pretend it's like a cancelling down. Okay, again we've got a couple of methods. The x method is to say x equals log to the base 2 of 16, which means you kick the 2 across here as a base, making that a power. So we have 2 to the power of x equals 16, and then you can rewrite 16 as 2 to the power of 4. And now we can notice that the bases are the same, so that we can equate the indices. So therefore x equals 4. So we write log to the base 2 of 16 equals 4. Now the other way of doing it would have been to notice in the first place that 16 is 2 to the power of 4 and everything else was as before. Then you can use this rule where you can bring that power down to the front over here. So we have 4 log to the base 2 of 2. And from before, this really equals 1. So we have 4 times 1, which is 4. Now for this one, the x method doesn't really work so well because you already have an x in the expression here. So we'll keep it simple and we'll rewrite it as x to the power of half. Then you can use the rule from before where this power can be brought down to the front over here. Half log to the base 2 of x. Can't do anything further. This one relies on the first log law or the log law of multiplication. So what you can do is first of all notice that they have the same base, which means you can then apply the log rule. So what you have to do is write log to the base 6 of a large bracket, and because these are adding, you can basically turn that to a multiplier inside the bracket. And what goes in the bracket is your 3 and your 2. And then you simplify what's in the bracket. So we have 3 times 2, which is 6. And from before, if we have the same base and same argument, you can cancel that down to 1. So the answer is 1. Now this one can be done a couple of ways. The first way would be to notice that 1 over 5 is the same as 5 to the power of negative 1. Then you can apply the power rule, I'm not sure what that's called, you bring that down to the front over here. So you have negative 1 log to the base 5 of 5. And then here again you notice that these are the same numbers, so you can cancel that off to 1. So the answer is negative 1 times 1, which is negative 1. Now the other method would have been to notice that you could have written it as a division, 1 divided by 5 over here, and then you can use the division log rule, which means you split it into log to the base 5 of 1, take away log to the base 5 of 5. And hopefully you remember that if you have a log of 1, that equals 0. And if you have log of the same number, basically you get a 1. So you have 0 take away 1, which is negative 1. Here's another one. This time you notice a minus and you've got the same base. So you can then use the log rule of division. So you write it as a one large log, and you would turn it into a division, and what is the positive goes in the numerator, and what's in the negative goes in the denominator. So you have 10 over 2. Then you simplify that, so you get log 5 of 5, and then you can hopefully see that that just cancels down to 1, so you get 1. And now this one is a combination of division and multiplication, so you can do it all in the same hit. It only works though if you have the same base here. So we're going to write everything to the base 2, and we're going to write a large fraction in the middle, and the ones that add together actually get multiplied in the numerator up here. So we have 10 times 8. The one that gets subtracted ends up being divided in the bracket, so we have 5 over here. Then the next step is to see if you can simplify any of the numbers. In this case you should see that 5 and 10 can be divided by 5, which gives you 1 and 2 respectively, and then you can simplify 2 times 8, which is 16. The rest has stayed the same, And then hopefully you can see that log to the base 2 of 16 is log to the base 2 of 2 to the power of 4. And then you can bring this power of 4 down to the front here. So you have 4. And if you're sharp, you don't even have to write the log to the base 2 of 2, but I'm just putting in there for you to see what's going on. And the final answer is 4.